The cells of the brain depend upon a constant supply of oxygenated blood in order to function. Cerebral blood flow is the amount of blood delivered to the brain in a given time. The pressure that keeps the blood moving through the brain is called the cerebral perfusion pressure. Cerebral perfusion pressure is the pressure difference between the mean arterial pressure and intracranial pressure. The cranial cavity of the skull, which is fixed in size, contains 80% brain tissue, 10% blood, and 10% cerebrospinal fluid. The normal intracranial pressure is 10 to 15 millimeters mercury, which is evenly distributed to all of the contents of the skull cavity. Cerebral autoregulation allows cerebral perfusion pressure to be maintained over a wide range of blood pressure or mean arterial pressure changes. Since the intracranial space is fixed, an increase in the volume of any of its contents will cause an increase in the intracranial pressure and compress the remaining structures. Intracranial pressure can be increased if there is mass effect, such as bleeding around or into the brain, or if swelling occurs. In addition to the brain, blood vessels get compressed and blood flow within them decreases. This then leads to ischemia of the cells of the brain, leading to edema or swelling of the brain tissue. This becomes a vicious cycle of ischemia, edema, more edema, again and again until the brain cells die. Hypercarbia, increased carbon dioxide in the blood from hypoventilation and hypotension, cause cerebral vasodilation. When there is cerebral vasodilation, the blood volume increases inside the skull, leading to an increase in intracranial pressure and a decrease in cerebral perfusion pressure. As intracranial pressure increases and approaches the mean arterial pressure, the cerebral blood flow to the brain cells decreases, resulting in decreased cerebral perfusion pressure. As cerebral perfusion pressure decreases, compensatory mechanisms attempt to increase the cerebral blood flow. This results in further intracranial pressure increase, and the cycle continues. When the intracranial pressure is too high and has exceeded mean arterial pressure, blood flow to the brain stops. As intracranial pressure continues to rise, the brain can be herniated through the base of the skull.